Okay, Mr. Baumer here, and welcome back. We are continuing in Unit 8, which is all about factoring, and it's important. I always like to remind you, you gotta know what factoring is, all right? What this concept is, and again, it's taking an expression and rewriting it as a multiplication problem. All right, so we're creating a multiplication problem where there wasn't one to start. All right, we'll see next chapter why that's beneficial to us. You're like, oh, why do I want a multiplication problem? Well, we'll show you next chapter when we get into quadratics why that's an important concept. But let's take a second and remind ourselves the types of factoring we've done so far. Greatest common factoring, right? Is there anything I can pull out of every single term? I don't care if there's 10 terms. Can we pull anything out of the same thing out of every term? If so, then we should. Then we worked on greatest or factoring by grouping. Greatest common factoring, then factoring by grouping. Now, how did we know when to use factoring by grouping? Well, remember 4 terms, all right? When there were 4 terms, that's a pretty good indicator that you should at least try factoring by grouping. Then, last class, we were working on factoring trinomials. Trinomials meaning 3 terms. Well, how did we factor those? Remember what we did, and you all did very well in class, all right? That we broke that middle term, that 10x or 5x or 2x, whatever it was, we broke it into 2 terms. So then we had 4 terms. Then we factored by grouping, all right? So today we're going to work on special cases of factoring, all right? 2 special cases. So let's start that. Let's look here. The first one we're going to look at is called a perfect square trinomial. That's the first special case we're going to work on. Now, if you remember last unit when we were learning how to multiply polynomials, what if I gave you x plus 4 and asked you to square it? Now, those of you that got it right on the test, all right, knew that that meant you had to do x plus 4 times x plus 4. All right. Those of you that did it wrong fell for that common mistake of just giving this 2 to everybody here. Now, what we're going to try and do with these perfect square trinomials is it's a polynomial that can be factored as something squared. All right. That's what we're going to try and end up with. We're going to try and end up with 2 terms in here, but this whole parentheses being squared. All right. That's what perfect square trinomials can be factored as. So keep that in mind as we get started here. But the good news, all right, there's good news here. If you didn't learn to recognize perfect square trinomials, if you didn't learn to look at this and say, hey, wait a minute, that's a perfect square trinomial, you can still factor these correctly by applying the techniques we've already learned. And let me show you that. All right, this is the old way. This is the way we would have done it last week. And let me show you that it still works. We can still end up with the right answer. So here's my thought process. Is there a greatest common factor? And no, there's not. So then I noticed that there are 3 terms. Wait, 3 terms, that's a trinomial. And how did we factor those? We were trying to break this term right here into 2 different terms to give us 4 terms that then we would factor by grouping. So let's look at that. How did I do that? Well, if you remember last week, we did the x factor. So what goes up here? Well, that's 1 times 36 is 36. What goes down here? 12. Now, I need 2 numbers that multiply to 36 that add up to 12. That's positive 6 and positive 6. Now, what did I do with those? Well, did exactly what we set out to do. I had my x squared still. I have my 6x, and I have another 6x. All right, we've broken this 12x into 2 terms, and I still have my positive 36. Now, how do we handle those? Well, then we factor by grouping, because now there's 4 terms. All right, so I'm going to try and factor these 2. All right, what can I pull out of those 2? Well, I can pull an x out of both of them. Is the greatest common factor times what? What does that leave me with in here? Well, I'd have to do x times x to get my x squared, and I'd have to do x times a positive 6 to get my 6x. And then last week, of course, I encouraged you to immediately rewrite this and then ask yourself, is there anything that goes here? that would give me these two terms. And if I put a positive 6 there, 6 times x gives me 6x, and 6 times 6 gives me 36. And then how did we finish it? Well, we finished it by pulling an x plus 6 out of each of these two terms. And what did that leave me with? Well, that left me with another x plus 6. Now, I want you to see that this is x plus 6 times itself, which can be simplified by saying x plus 6. I know that looks like a b, but it's actually a 6 squared. Now, this took a lot of work, and it took a couple minutes to do. So here's the trick. If we will learn to recognize perfect square trinomials, we can do these a lot quicker, a lot more efficiently. So here's the process. Are there three terms? So there are three terms to this problem. All right. So it's like, yes, I checked that off. Hey, is the first term a perfect square? 4x squared. Yeah, that's 2x being squared. Is the third term a perfect square? 9. Hey, wait a minute. That's 3 being squared. So we've done those. Now, is the middle term 2 times the product of these two? So let's look. 2x times 3. That's 6x. Double it. Hey, that gives me 12. Don't worry about the sign right now, plus or minus, so we'll handle that in a second. But watch what I did again. 2x times 3, that's 6x. Double it. Hey, that does give me my 12x. So it is a perfect square trinomial. So how do we factor? Well, we can factor it very easily. All we do is this. Take this one right here, 2x. Take this one. And now, what sign do we use? We use the sign of the middle term. And then it's squared. Very quick to factor perfect square trinomials if you recognize that they're perfect square trinomials. All right? If you don't and you go the x factor route, the trinomial route that we learned last week, you still end up with the right answer. It just takes a little longer. So let's go back. Let's try this next problem and look at our checklist again. Look at the way to train ourselves to think about these. First of all, I'd start with, is there a greatest common factor? And there isn't. So then I'd say, hey, there's three terms. I can either go the x factor route, or maybe it's one of those special cases. Maybe it's a perfect square trinomial. Are there three terms? Yes. Is the first term a perfect square? Wait a minute. What could I square to end up with this? Oh yeah, 5x. Is the third term a perfect square? Hey, what could I square to end up with this? Hey, it is. Is the middle term, is this term right here twice the product of these? Well, 5x times 2 is 10x. Double it, 20x. Hey, it is. So now I can factor it. This one right here. This one right here. Use the sign of the middle term. See, if that were a plus, you'd use a plus right there. And square it. Now, this one, you notice I set up a little differently. Because I want you to be able to recognize what number do you want to be right here for this to be a perfect square trinomial. Well, this one could be 4z being squared. And this one could be 2 being squared. So what number do I want to be there to make this a perfect square trinomial? Well, 4z times 2 is 8z. And if I double it, it's 16z. All right. So if this number right here were 16z, how would I factor it? Well, it'd be very easy. You just say 4z and a 2. And then what do you use in here? We use the sign of this one. So there and square. Now, that is a, how do you factor this first special case? Perfect square trinomials. Now we're going to look at one more type of special case. And this one is called the difference of two squares. All right. Now, the difference meaning subtraction. All right. A lot of students forget these words. Difference means subtraction of two things. All right. Those should be indicators of when we may consider this. All right. Now, it's going to be factored in the form a plus b times a minus b. So we're going to end up with something like x plus 2 times x minus 2. You'll notice the only thing that's changing here is the sign between the two terms. Now, that's what we're going to try and end up with in this second special case we're working on, the difference of two squares. Now, just like on the previous page, If you don't recognize this shortcut, you can still get these right. But this way it's a little harder to get them right, because if you wanted to think about this as a trinomial, you'd have to do this. You'd have to stop for a second and say, this is the same thing as x squared plus 0x minus 81. And then try the x factor route, which what goes here? Well, up here would be negative 81, and down here would be 0. Now, what numbers multiply to negative 81 that add up to 0? Well, the only way two numbers are going to add up to 0 is if they're opposites, all right? So it's plus 9 and minus 9. And we could go the long route again. X squared plus 9x minus 9x minus 81. Factor by grouping because there are 4 terms. I can pull an x out of these two terms times x plus 9. Immediately rewrite the x plus 9 and ask yourself, is there anything that goes here to account for these two? And negative 9 would give me these two. How do I finish that? Well, it's going to be an x plus 9 and an x minus 9. Now, you notice this isn't x plus 9 squared, all right? These are not the same things. Now, you could do that, but a lot of students, the problem is, will not recognize that to put this term in. So this one, it's very beneficial if you learn the difference of two squares. Perfect square trinomials, like on the last page, if you forgot that, how to do that, you could still end up with the right answer. This one, if you don't really learn this technique, you're likely to not end up with the right answer. Now, here's the way we consider these. Are there two terms? Again, remember, 4 terms was an indicator that we should be doing factoring by grouping. 3 terms was an indicator that we should be either doing the x factor or recognizing it as a perfect square trinomial. Now we're dealing with 2 terms. Well, the first thing I notice when I look and there are 2 terms is there a subtraction symbol between them? There's no such thing as the sum of 2 squares. So if I notice that there are 2 terms, and that they're separated by subtraction, is the first term a perfect square? Well, yeah, that's x squared. Is the second term a perfect square? Yeah, that's 9 squared. Now I'm ready to factor it. It's just x plus 9 and x minus 9. Here, same thing. I notice that there are 2 terms, and I say there's a subtraction symbol between them, and I'm jumping up and down going, I wonder if this is a perfect square. I wonder if this is the difference of 2 squares. Well, this is something squared, and this is something squared. So it is. So it's z plus 11 and z minus 11. This one, same thing. A little different though. All right, 2 terms. Over here, checklist kind of way to think about it, thought process. There are 2 terms. They're separated by subtraction, so it might be the difference of 2 squares. Is this first thing something squared? Yeah, that'd be 3v being squared. Is this term something squared? Well, yeah, that would be 4 squared. So it is the difference of 2 squares. It's the difference of 2 things being squared. How do you factor it? 3v plus 4 and 3v minus 4. All right, so those are the special cases that we need to learn. We needed to learn perfect square trinomials, and we needed to learn how to factor the difference of 2 squares. All right? As long as we're good with those, we'll be very good, and we can get you where you need to be by the end of class, just like we did last week. You all had a very good day last week. Now let's have another very good day tomorrow in class. So appreciate you. Hopefully you were focusing. If you want to watch the video again, you can. All right. If you want to go into the Khan Academy and do some practice, all right, they have some very good practice problems related to factoring, and we're actually going to spend some time in the lab next week where all we do is practice on the Khan Academy. So we will see you tomorrow. Later.